It looks like a train, but it floats above the tracks, powered by magnets, and it's faster than airplanes. Now imagine that same train inside a near vacuum tube, blasting forward at the speed of sound. This isn't science fiction. From Japan to China to Elon Musk's Hyperloop, the race for the world's fastest trains is happening right now. Trains were once the slow, smoky backbone of industrial revolutions. They connected cities, built nations, and carried armies. But in the 20th century, they were left behind by cars and airplanes. Now the 21st century is rewriting the rulebook. Maglev technology and vacuum tube travel are pushing ground transportation to speeds once reserved for jets. And if these projects succeed, the way we move across the planet will change forever. The rise of Maglev. Maglev stands for magnetic levitation. Instead of wheels grinding against rails, the train floats a few centimeters above the track using powerful magnets. Japan's L0 Maglev holds the official record at 603 kilometers per h, 374 miles per hour, set in 2015. Test passengers describe the ride as strangely smooth, like gliding on air. China's Maglev projects already operate at 430 kilometers per h between Shanghai and the airport, with new prototypes pushing for 600 km/h+. Even South Korea and Germany have tested Maglev lines, though cost has slowed expansion. Without friction, Maglev trains are smoother, quieter, and faster than anything on rails today. Hyperloop and vacuum tubes. But Maglev is just the beginning. Enter the Hyperloop. The concept: put a train inside a low-pressure tube, removing almost all the air. With no drag, the vehicle can accelerate to 1,000 kilometers per h, 621 miles per hour, nearly the speed of sound. Elon Musk made Hyperloop famous in 2013, sparking a wave of startups. Virgin Hyperloop built a Nevada test track and carried human passengers at 172 kilometers per h, small compared to the goal, but proof of concept. European projects like Heart Hyperloop in the Netherlands and Zeleros in Spain are also testing scaled versions. The dream is simple: city-to-city travel faster than jets, but with the convenience of subways. The engineering challenges. Of course, pushing trains to jet speeds isn't easy. Maglev costs. Building tracks lined with superconducting magnets can cost tens of billions per line. Hyperloop seals. Keeping hundreds of kilometers of tube near vacuum is almost science fiction by itself. A single leak could compromise the whole system. Safety. At 1,000 kilometers per h, a small crack or mechanical failure would be catastrophic. Engineers are still figuring out emergency braking, passenger evacuation, and redundancy systems. Still, every breakthrough brings the dream closer: the global race. This isn't just about speed, it's about prestige and power. Japan plans to open its Tokyo to Nagoya Maglev line by 2027, cutting the 90-minute trip down to 40 minutes. China has the largest high-speed rail network in the world, over 40,000 kilometers, and is aggressively testing maglevs to dominate transport. Germany's Transrapid system was the first to operate commercially, and while it shut down, its tech inspired Japan and China. India is pushing ahead with traditional bullet trains, but is already eyeing maglev partnerships. Whoever masters this tech first doesn't just get faster trains. They shape the future of global trade, commuting, and travel. History in motion. It's worth remembering how we got here. The steam locomotive in the 1800s could barely manage 30 miles per hour. By the 1960s, Japan's Shinkansen bullet trains broke 200 kilometers per h, stunning the world. By the 1990s, France's TGV reached 500 kilometers per h on test tracks. Every generation thought they'd reached the limit, and every generation was wrong. Now, Maglev and vacuum tubes are preparing to make trains not just competitive again, but the kings of speed. Life in a high-speed world. Imagine this. You live in Los Angeles but work in San Francisco. Instead of a 6-hour drive or a 1-hour flight, you board a train and arrive in 30 minutes. Families could spread out, cities could merge into mega regions, countries could shrink into commuter belts, business trips would feel like quick subway rides, and beyond lifestyle shifts, the environmental impact is huge. Maglevs powered by clean energy produce a fraction of the emissions of planes. Hyperloop systems could, in theory, run nearly carbon-free. High-speed rail wouldn't just change travel, it would change how humanity organizes itself. Trains started as smoke-belching locomotives, crawling along steel tracks. Now they're machines that float on magnets, and soon they may scream through vacuum tubes faster than jets. And here's the twist. When the ground beneath your feet moves at the speed of sound, the world doesn't just shrink, it bends. The train of the future isn't just transportation, it's the ride that rewrites the planet.